Hello, I'm Jack. Welcome to my YouTube channel, Practical Programming with Dr. Su. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, we discussed how to map an image texture onto the surface of a 3D cylinder. In this video, I will explain how to use the texture framework created in the texture.ts file to create a 3D simple Sinc surface with texture. In order to create a texture, I have added 9 images to the DRST folder, as we did in the last video. This image have the size 512 by 512 pixels and the same PNG format. Here are the 9 images we are going to use in this example. Let's consider the texture coordinates for 3D simple surfaces. We start with a unit cell that contains 4 vertices. As shown here, you can see P0, P1, P2, and P3. We also show in 4 texture coordinates T0, T1, T2, and T3 for this unit cell. This unit cell can be divided into 2 triangles P0, P1, and P2, P2, P3, and P0. When creating 3D simple surface, we normalize the vertex position into the value range of -1 to 1. Here, let's take the P0, this point, and the T0 as an example. Or other points can do the same procedure to process other vertices. You can see for P0, we normalize the P0x and z component into the -1 to 1. Now we want to map T0 to the P0. We define U component of the text T0 to 1 plus P0x component divided by 2. Here, if this component, P0x component, change from -1 to 1, T0U component will change from 0 to 1. For V component of our text coordinates, we define 1 plus P0Z component divided by 2. When P0Z changes from -1 to 1, the T0V component will change from 0 to 1. Here we will use the gate tool to clone the source code used in the last video. Here is the download link at the GitHub repository. From this link, you can download all the source code used in the last video. Now open a command prompt window and run the following command: git clone, and paste this link. This will generate a WebGPU 36 on your local machine. This folder contains all the source code used in the last video. Now we want to change this folder's name to GPU 37. So rename 37 and cd into it. At this point, we are going to start Visual Studio Code with the command code period. This is a Visual Studio Code interface. Okay, we can close this welcome page. Here contains all the source code used in the last video. Now open a new terminal window. Run the command npm install to restore all the npm packages used in this example. Okay, finished. Now all the installed packages are stored in Node Modules folder. First, we need to generate text coordinates for 3D simple surface. From SRC folder, open surface-data.ts file. Now we need to add a new private function called normalize UV to this file. we add here, normalize UVG. Here we use the formula we just discussed, 1 plus P0 X component divided by 2 to this U component. This is the V component, so use Z component here. Here we have a scale, because the PT scale to -1 to 1, so we need this scale factor. Here, the Y component doesn't matter in this example. We only need the X and Z component for UV. Now we found the create call methods here. Here we need to add 3 new input arguments. Firstly, the scale with default equal to 1, and the UL equal to 1, and the VL with 3 input arguments. We then need to add UV data for this unit cell here with new code. First, we define UV array. Then we define text coordinates for these 4 vertices of our unit cell by calling the normalized UV. So we convert the vertex position into the UV coordinates. So we then push these UV coordinates into this array with 2 triangles. Next, we need to return the UV data. Okay. Next, we need to make corresponding changes to the simple surface data. Try to find the simple surface data here. First, we need to add 2 input parameters. UL equal to 1, VL equal to 1. Here we need to replace this code snap here with new code. Here we add the UV array. Then we call this method with new additional 3 input parameters, scale, UL, VL, when we call create call methods. In this case, this data also contains UV data. So here we push this UV data into this UV array. Finally, we need to return this UV data. Copy this. Change this color data to UV, and also here the UV. Now we finish the modifications to this file, so we can save this file and close it. Next, we need to make some changes to the index.html file. From DRSC folder, open this file. First, we need to change the 36 to 37 because this is 37th video series. Here we also need to change the cylinder to Sinc surface. The input parameter here we used is the same as those used in the last video. So we don't need to make any change to the input parameters. Now we can save this file. Next, we need to make some modifications to the main.ts file. From src folder, open main.ts file. We need to replace its contents with new code. You can see here we first introduce create shape with texture method from texture.ts file. Then we introduce simple surface data from surface-data.ts file. This function contains the UV data already. Next, we introduce the Sinc function from math.func.ts file because we want to create Sinc surface, so we need this Sinc function. Inside this create shape methods, we first call the simple surface data with Sinc math function to create the vertex data, including the position, normal vector, and the UV data. With this data as input, we call create shape with texture methods to generate our textured Sinc surface. here the code try to set the input default parameters. Here text file we use break.png, and we set address mode for UV directions as repeat. You can also set other options, for example, middle repeat or climb to edge. Here we also set UL equal to 1, VL equal to 1. This is the default, the upper limit for our texture coordinates. We then call the create shape a function to generate textured Sinc surface with default parameters. The rest of the code is used to regenerate the textured Sinc surface with the input parameters specified by the user. Now we finish the modification to the main.ts file. So now we can save this file. Up to now we have finished all the programming. Now we can run the following command on the terminal window to bound our TypeScript code in production mode. npm run prod. Okay, the bound file is created successfully. Now we can click the Go Live link from the status bar area to open Chrome Canary to view our Sinc surface. So click this link. Here is our textured Sinc surface with the default lighting and texture displayed on this page. From this drop-down menu, we can choose different image. For example, earth, grass, Grand Canyon, Juzago, marble, New York City, wood, and Yellowstone. We go back to the default break. You can also play around with different U lines and V lines here. Now we have completed this example. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time.